I'm filming a long overdue video. This was requested some time ago, and another channel was talking with somebody, and they were looking for a die cutter that would cut plastic. Well, I wouldn't call it cutting plastic. I would call it probably more deep scribing plastic, particularly on the thicknesses that we're going to see here in the video. But apologies to the person that asked for this quite some time ago. We've been quite busy kind of playing with a new toy that I'll show you here in a second. Actually, several new toys here in the shop for model building. And just now getting back to doing some of the die cutting. So the die cutter that we're using is the Silver Bullet. This is a quasi-commercial grade machine. It's not meant for doing this. I will point that out. The manufacturer will disavow you for doing this type of cutting. But and they're out of England, so trying to get any replacement or something on it, and if they figure out that you've been cutting heavy stuff and it failed, well, you're going to be on your own for that. Now, having said that, we have been doing this for about, this is our third year now, I think, 2.5, 3 years that we've had the machine. It's been doing quite well. We do go through a lot of the stickies, and if you go on their website, you can see their sticky mat. We do go through a lot of their stickies. They originally had some little dots that they sold to stickify the mat here that you can see in blue. They have since stopped doing that, or at least the last time I ordered some sticky, they came out with this film, and not a real big fan of that. I really wish they'd go back to the stickies, at least for our purposes. Now, what you're looking at here might be a little bit confusing. The piece we're actually cutting, and I've already started one pass on the cuts, is a 0.04 inch thick, or approximately 1 millimeter for our metric friends, thick piece of plastic. And over here, in order to get the wheels to lock down that are back in here, and there's actually two behind where the cutter is currently located, to get them to lock down tightly and provide enough friction and movement, I go ahead and lay in some extra pieces over here, because we're actually using quite a bit of pressure, at least as far as this machine is concerned. We do our layouts in a program called Rhino. We do also do 3D designs, so actually this particular piece, let me back up here, we'll come back to this in a moment. This particular piece that we're cutting out is going to be for a ball turret for a flying ship that's going into a model contest this year. So these are the actual pieces that were modeled, and it just went through some various phases of where I keep copies so that we can back out and recover if we need to. So it progresses. If I were to go back over here, and we'll turn on some other stuff here in Rhino. This is the actual gun here, what it will look like. This will be an acrylic sphere, and then these will be some acrylic rods that are lit by LED that my son is building. These are some frames. These here are made out of a high quality manufactured board. These pieces down here will be done on a different type of printer. I'll show you that in just a second. And these here circles were the first ones that we've done on our newest toy, which is out here in the shop, and it is a drill mill, complete with rotary table. We've got vise and set up with DROs, and then in another crate that's not unpacked yet, we got a lathe as well, a 7x16 lathe. So just to give you an example, some of the things that we build, or actually I should say my son builds, I just kind of help out, I get the sanding jobs, are things like this little steam engine that will be duplicated 5 times over. We do a lot of resin casting here in the shop as well. These are the parts, or quite a few of these are parts that will be used to make that. And then these pieces here, as an example, were all cut with the die cutter. The holes were drilled out by hand. That's a little small manual drill press because I've yet to find one that works really well for drilling through plastics and other things. Actually, here's the little manual drill right there. Comes from a very kind of self-thought of place because they're very expensive for what they sell you. And here's the components for the gun. Some of these were done on table saw. These pieces for the center console were actually all cut out with the die cutter there as well. There's another cockpit component for the forward cockpit that he has. You can see these curved pieces and stuff around the edges. Those were all cut. The straight ones are obviously just stripped because they're easy to do. Rivets, handmade rivets and stuff will end up going into those. It's quite a little production he's got going on. Let's see. There was one console that he had done, but I don't see it right away. If I can think of where it might be. Like a lot of these components for this gun here, he's in the process of redoing these for this year, so these were from a prototype that he did last year, but that gives you an idea of some of the types of cuts, circles, etc. that you can do with the die cutter. Some people ask me, why a die cutter and why not a 3D printer? Well, a die cutter is a lot faster, number one. The materials are far less expensive. Over here, we've got a rack. We found an online place, U.S. Plastics, where we buy sheet size plastics rather than buying the evergreen and such, because it's much, much cheaper in sheet form, even with the shipping. But back to why the die cutter versus a 3D printer. Speed, cost, and accuracy, actually, in a lot of cases. Now, with another new toy that I mentioned a while ago, we're finding that accuracy, at least on small parts, is not much of an issue. This is just came into the shop not too long ago. We've been setting it up and doing our first prints with it. There will be more videos on it later. At the moment, I can't disclose the name of it. The manufacturer has asked that we not put videos and such up quite yet, so not going to be doing that. Now, back over here, the 3D prints, just to give you an idea of what some of those look like. Let's see if we can zoom in. I might have to set up the microscope so that y'all can see these. This is 0.0, well, don't think I'm going to be able to focus in that close with the video. There you go. Don't know if you can see it very well. I've got an AM scope I'll set up in the future and put it up underneath there. This is some brand new resin we just got literally this week, specifically for this printer. Surfaces are amazingly smooth, very accurate. The steps are 0.05 inches and as specified in Rhino, and I'm measuring them as coming out as like 0.0511. So we're pretty darn close and dialed in. Anyway, back to the die cutter. So in a moment I'll be turning a vacuum on, because one of the biggest things with cutting or scribing plastic is that a lot of the little peels and stuff of plastic that come up, featherings, tailings, whatever you want to call them, they do tend to get all over the place in the shop as well as also up into the printer. So you definitely do not want to get these little plastic shavings off up in where the belt is or where the carriage rides. So what I've done is I just use either the shop vac if it's handy, or the household vacuum cleaner, whichever one's closest. And usually put a pair of earmuffs on, and I sit here and wait while it cuts. Now, the software that came with the printer when we got it, I don't know if it has changed, is a piece of software called Sure Cuts a Lot. So what we do as a workflow is we design in Rhino, the program that I showed you here a while ago. We come up with our parts, and then if I go into like a top view, pardon the camera moving around a little bit, I don't do too many of these videos, so still learning along the way. What I do is I generate a top view of it for him here, And then we select the items that we want to export, and we export them in an Adobe Illustrator format. So this is a 2D drawing, so you cannot export 3D and have the Sure Cuts a Lot software recognize it. You have to do, for example, a dupe edges that's in Rhino in order to get these outlines. If, for example, you've designed surfaces, which we've done here, and I think it's dupe face edges is the actual command. And once you have duped those, then you can copy them over here. And these are actually spread out in 3D if you look at it from the side down here. But whenever you look at it from the top, which is the window we'll be printing from, everything will print into a 2D plane. That's true whether you're sending it to the printer or if you're sending it to a laser printer. So a lot of times what I do is I'll print these off for him once he tells me what his dimensions are, and then he'll cut them out on paper and make sure everything fits, do trial runs and fittings, for example. And I also use Rhino here for the mill. For example, this piece right here was the circles that you see right here are my mill cutter offset. So what I do is I go ahead and set up my mill cutter in the center of the circle that I want to machine out, and then I just do a dimension and it tells me what my offset center to center is, and so I can go out, set my workpiece up on the rotary in this case, turn on the DROs, zero everything out against the rotary table, do my offsets, and voila, I can spin out a circle there. One of these days I'll try to do a video of that as well. A lot of these are things that I'll be talking about along the way are actual practical how to do, or how, at least how we've found to do it over the last 6 or 7 years that he's been involved with model building. He has built quite a few models. He's been involved in Wonderfest for about 6 years. He's been involved with IPMS for about 4 or 5 years. And he's done quite well for himself. My younger son as well. So it's kind of become a family hobby. I like the toys and they like to build, so everything works out pretty good. Anyway, enough meandering. Back to the topic at hand. Once we've designed this in 2D, then I do an export. I actually send mine out into a network attached storage array that I have here in the house. That way I've got like 2 or 3 different printers, or computers. There's a dedicated computer that I use for the 3D printer. And out on the NAS, it's set up in array configuration, so everything's a little bit more safely backed up. Because you spend a lot of time developing these things, and a lot of times we'll go back with models a year or 2 later and pull up bits and pieces, so it's kind of nice to have everything organized and you know where it's going to be at. So anyway, once we've exported those files, we'll go over to Sure Cuts a Lot. Let me bring him back up here. What I've done here is imported that .ai file that I exported from Rhino. I have relocated it and turned it down here into the bottom corner, which lines up with where I have homed and the cutter head, which is actually this little tiny thing down up underneath here. See if I can clean it off. I don't know that y'all will be able to see it. Maybe you can see it somewhat there. See if I can focus this thing in. Apologies for all this. I actually hadn't intended to video this. I just kind of jumped in and started doing it. I said, I owe somebody a video, so here you go. Anyway, what I'm going to do now is we go over to the computer. We go into Cuttter up here at the top. We say cut with silver bullet because that's the only cutter that we have. It comes up with a couple of options. Probably my biggest grumble with the software. In order to scribe plastic, you have to make multiple cuts, particularly on thicker pieces. And by the way, I would not try to do a piece thicker than 0.04. You might be able to, but I think that's about the limit, and that's because of the shape of the blade. And I will mention that they do have different blades. This particular one here is about, I think it's their 60-degree angle. And so it's very long, very thin, and it'll cut really deep for us, which is what we want. Or scribe. I should really say scribing. Although you can effectively cut through the plastic if you make enough cuts. You do have to be careful, however, that blue mat that's underneath, that you don't cut too deeply into that if you accidentally go through. Typically what we'll do is go anywhere from about half to almost all the way through, and then we just twist it until it breaks out of the frame. So back in the cut settings, we'll go down here. I set it up to 5 times. This is my grumble. The current version of Sure Cuts a Lot that I have will only allow you to go up to 5 times cutting. It would be really nice if you could go up to about 15 or 20. And the reason for that is that if you have any slippage in a part, that blue mat that's being held down by the compression of the wheels, your future parts will get off. And whenever it goes back to the original part, in this particular case you can see I've got quite a few parts out here on the cutting platform at one time. Whenever it goes out to the further pieces, it may be a little bit off and you end up ruining the entire cut session. So you do have to watch this. You cannot get up and walk away from it. Anyway, we go ahead and I set this up for 5 times. You could do it 1 and repeat a bunch of times if you wanted to. Typically for the plastics I'll do anywhere from about 90 to 120, and pressure from about 150 to about 220. In this particular case, in case you can't read it, I've got it at 90 millimeters per second and about 203 on the pressure setting. So the next part here is going to get really loud. There might be a way on the phone here to mute. I don't know how to do that, so I apologize for the noise that you're going to hear. But what I'm going to do is go ahead and make a quick pass and let you see this thing in action. So first thing I'm going to do is put my earmuffs on. And then let me go ahead, and all we have to do is press the cut button here, and she's moving and going. Now I'm going to turn the gas. Okay, now one of the things that happened there, and I'll point this feature out that I like about the shortcuts a lot, is as you can see, number one, it had no issue going through scribing the plastic there, and it's relatively quickly. It could probably actually go a lot faster, but just for accuracy and stuff, this is about the setting I found that I'm happy with. Now, while we were doing that, my PC battery decided it was going to play out, and so it shut down. And we haven't finished the number of cuts that we want to do on here. So one of the things that you can do, as long as you're up here on the control panel, there is a repeat button here. So I would like to make one more set of passes on here because this is a thicker piece of plastic. So what I'm going to do is I'm just going to hit repeat and it'll do the same job all over again. Give me 1 second with the head earmuffs and we'll do that. I just turned the vacuum off so y'all get an idea of how loud the actual printer itself is. And also, if you notice, some of these shapes are, I wouldn't call them super complex, but they're not squares or circles. The other thing I'll note here is that the thicker the plastic, the larger the minimum circle that you can cut is. Let me turn the vacuum back on. And but it does very nice circles. A lot of times what I do if we're doing drill outs and stuff, and he's like doing his rivets on odd shapes that are being cut out on here, I'll use the array curve function on Rhino, and I'll just plot out all the points, and then the plotter here will mark where the drill points for him to drill. Saves him a lot of time. Sorry about that. Actually, we are done with the cuts now. So what we'll do is come around to the back of the machine. These are the little hold down levers. We just pop those out. We'll pull this out. Now typically what I'll do here too is we found the best process before just popping these out, because whenever the cutter head is going through the plastic, and not so much here today, there's some right there, it'll leave a little raised ridge where it's pushed the plastic to one side instead of actually cutting or scribing the plastic out. As you can see, this mat's been used quite a bit, and this is the reason why I started using the vacuum and stuff to clean off the top. Otherwise it becomes unusable a lot quicker. Really extends the life of the cutting mat, namely the sticky surface that it has on here, even though it is quite noisy, especially for videos. So next time I'll try to plan a little bit better if I make another video, figure out how to do a mute or put it into some editing software to remove the vacuum. But for right now, that's where she's at. So what we'll do next is we just peel off the piece that we just cut scribed. And then in this particular case, don't know if you can see daylight, but a few cases it went all the way through. Ideally, if my PC hadn't died, I probably would have set that last cut to 3. So that all told, what would have been done here is about 18 passes on each one of those. One pass was already done before I started videoing this. But you can see the shapes are followed really nicely here. Once these get glued up, these will actually go onto a core that's back of a Tesla gun that he's making. And so that will be a face on each side. And then it should stick out the back a little bit to kind of hide the block up in the ball turret. And then one of the next cuts I do will be a hex shape with the circle cut out as well. And then he can glue that onto the front of his turret there for him. Anyway, I think I'll wrap it there. Hopefully, I know this is like a year later, but hopefully this gives you an idea of what doing plastic cuts with a die cutter are like. Y'all have a good one.